Okay, guys, I figured I'd do a quick little walkthrough of everything that is the StrayLights bike, or also Beautiful Disaster. Everything on here is basically the best of all my fuck ups, which is why we go with Beautiful Disaster. And so digging into everything, we'll start right off the bat. This was a piece of crap bike, so I just wanted a frame, and for the cost of a frame, I was able to find a whole bike delivered for 300 bucks. And I was originally an e-bike already. And for this build, I wanted an e-bike just because of the amount of weight I was putting on it. And I wanted to serve double duty. It was going to be used for the critical mass rides in Chicago. But then we also had some group rides that were a little bit faster pace, shall we say. So it's capable of going way faster than it should. It's touched 40 a couple times, which it shouldn't do, but it'll keep up with most things. I'll put a picture up of what it looked like. So starting off, we go with the power plant. Everything is running off of the main drive battery. So everything. The original battery, wow, that's the original battery. This bike started life as a 36 volt, and it came with a 36 volt 9 amp hour, 250 watt motor. And well, that wasn't going to work because that would barely power my lights and music and everything else. So what I did is I stole the end caps off of the stock battery, and then purchased one of these. It's a 20 amp hour, 52 volt. Grabbed the cells out, and then 3D printed a case, which allows us to turn everything off. And we got to disconnect one little jumper wire for the panels, but if that's the right key. So it uses the stock key. I normally don't take the battery off the bike, but just to give you an idea of what we ended up doing. So I printed out the channel, kind of made it fit the stock battery channel. Default end cap, got the locking front, power on. I got a flip ski anti-spark in here to cut the power off. And then we have the panels. These are 8x32s, and 3 of them wrapped around, covered in polycarbonate. So I did that on all of them, all polycarbonate. Little kids like to touch shiny stuff, and some big kids too, so want to protect that. I also ride this bike everywhere, like anywhere. So dirt, try to stay away from water and mud, but if it's there, I'm going through it. So I want to make sure everything's protected. The other thing with this battery is, 52 volt. It's only about that big. So all that extra room. So instead of carrying a charger, I actually mounted a charger in the front with a little dividing wall to separate it. It's got a little blow motor in there, little vents. So all I have to do is carry a cable with me. The built-in charger is 4 amps. I carry this little cable, 15 foot, and I can basically plug in anywhere. It's 4 amps, 52 volts or 58 volts charging voltage. It's like 1.5 amps at 120. So just plug it in, and now you're charging. Keeps everything nice and clean. Don't have to carry any chargers around. Just carry a little cable around. And we just pop that off. That back on. We'll get our ambient lights going. That's the music. So that's the main power. And then for the drive, I got a 500 watt direct drive, old school. It's from 2016. Bought it from Ego Bike, I think it was. I've had that motor forever. It's currently running 1200 watts, 52 volts. and the rim is a double wall steel rim, and I've drilled it out. It's 10 gauge spokes because we've got a lot of weight and a lot of weight. What I found is with using the 10 gauge spokes, I don't have to worry about breaking spokes. I bend the rim a lot, especially if you're doing 35, 40 miles an hour on a 2-inch tire with, 300-400 pounds. Controller is just a 25 amp controller. It's from Grin Technologies. Again, this is their Infraron, discontinued in probably 2018, 2017, something like that. I'm using the Cycle Analysis version 3, 3.1, I think. Again, the same. It's the 2018 version. So motors got regen and all that stuff, which actually is very important because to make this LED disc fit on here, I had to disconnect the rear brake. This is just sitting here looking pretty. So the rear is running just regen, and then I've got the front disc, and those were swapped out instead of the default cable ones that came with the bike. I put the hydraulic kit from one of my other bikes on there. So that's the drive line. And then we go into the LEDs. So up front, we've got the demon eyes. Those are from the backpacks. It'll actually play any kind of JPEG, PNG, GIF, Shockwave Flash, SWF files, and it's got a little phone app that you can change all the stuff with. So that's running its own controller. It's running 5 volts. The wheels, we've got two 32 spoke. There's 21 LED pixels, double sided. It's just basically a giant disc that just kind of sits there. The rear one's weighted, so it'll naturally find its center. It's sitting on a bearing that is sitting on the edge of the hub motor, just kind of floating there. And then the front one is sitting on the front axle, and it's got a locking nut, so that this one doesn't actually, well, okay, so the axle locking nut isn't truly locking right now. And it just kind of sits there. And originally I wanted to get the disc to spin with the wheel, and that required either batteries on the wheels, or I was developing slip rings and that kind of stuff. But it turns out having the floating disc actually has a bigger wow factor. You get the same image regardless of how fast you're going, standing still, whatever, it doesn't matter. You get the same exact visual. And part of the beautiful disaster, if you notice, one spinning forward, one spinning backwards. When I laid out the template to create these, when I was wiring everything up, I completely forgot that one was going on the right side and one was going on the left side. So they're mirror reverse, which I was going to fix it, but it looks really cool with some of the effects. The wheels are running on one of these. This is a T1000, the Terminator, T1000K, I believe. This will do either 2000 or 2024 pixels. When I was building the bike, I basically learned like everything on here. So 3D printing, never did that before. Never did 3D design before. Designing the sound system, like I was spending so much time trying to figure all that out that I just didn't want to have to learn how to program any of the controllers. And the wireless controllers with the WLED, you could get a lot of cool standard stuff, but I wanted to do my own patterns. I wanted to design my own stuff. And you could do that with WLED too, but when I was looking at it, it just seemed like the learning curve was going to be too steep. And when I was looking at some videos on doing these, it looked like it was just going to be really easy. The downfall is I program it, have to put it on SD chip, and then that's it. It just runs it. So pluses and minuses, but it's really easy to set up. We'll do a little demo of, I think I got one of these panels that we can do. The only kind of nuanced thing of the way that I have mine wired versus the way someone else would potentially wire it is I have my controllers running at 12 volts, and then I have all of my panels and all the LEDs are running at 5 volts. Just because with the amount of LEDs that I have running the controller at 5 volts, the signal just couldn't penetrate. So I tried using repeaters, it didn't matter what I did. With the 5 volts, the signal just would get so far, and then certain displays No rhyme or reason, just certain displays, or after so much time, they would just start locking up or it would start glitching. So that took forever to fix. But controllers running 12 volts, everything else running 5 volts. Fixed everything. The frame and the back cube and the battery, those are running off of a T4000. It's a 4-channel version of this, capable of doing 4,000 pixels. 3 channels running on that. We got the right, left, and center rear. The battery is displaying the center rear image, but it's displaying it flip 90 degrees. So when you're looking at from the back or you're looking at an angle, it doesn't look the same. It looks like it's getting its own signal, so it doesn't look exactly the same as the back on most of the patterns. And then the frame LEDs are just playing the same exact signal that's on here. Again, the center signal in the back. And then for power, this is just a little one. I'm running two the buck converters to power all the LEDs. They're rated for 30 amps each, 30 amps at 5 volts. I'm pulling a lot more than that. So I do a lot of, if you see the patterns, there's a lot of dark, and I try to stay away from white, and I try to use more solid colors. So it's not turning on, because inside of each one of here is 3 actual LEDs in each little spot. So if you use more of a solid color, you're only activating one of them or 2 of them, which cuts down on the power usage. My buck converters are rated for about 300 watts combined, and calculating the full power of each panel, I can pull about 600 watts. They get warm. I was doing some tests when I had all this stuff torn apart, and typically I'm averaging right around 60 amps, 50 amps, but it will spike up closer to 100 amps between the two controllers. So it's not too bad. I got all my LEDs set at 20% brightness. Sometimes for certain events, I will bump them up a little bit, but for the most part, I just keep them at 20%. It's usually bright enough. It covers power. So all the power comes from the battery, comes up, we got our controller, and then I've got a whole set of relays, 12 volt buck controllers and everything, and then I've got buttons to turn everything on. So we've got the first 2 is the sound system, and then we could turn the wheels off and on, and then we could turn the panels off, and then we could turn the frame off. The front LED eyes are actually running off the cycle analysis, so if I really wanted to turn those off, they just got their own little pigtail that I can unplug. No switch there. So in the back is a storage box with 8 speakers. We've got 6 speakers in the back. We've got 2 up front. So we've got 2 5 1/4 Dayton ND 140s, and then in each tube on each side are 2 ND 105s Daytons, and then I got 2 passive radiators in the front. They're tuned to everything's tuned to a slightly different frequency, so I'm trying to get like the peak out of each one. 2 of the 4-inch are running on the front channels of a 4-channel amplifier, and they're running with the 2 up front. I think I got those ones cut off at 50 hertz or 55 hertz, and then the other 2 4-inch and the 2 5 1/4s, those are running on the rear channel, and they're running. I'm going to pull up the actual file, but I'm thinking I cut those off at like 48 hertz or 45 hertz or something like that. We'll see when we actually open up the file. So what we got in the tubes, this is the ND 105s, the 4-inch. This is just the passive radiator version from a different project, but what I like about them is it's a solid aluminum cone with a butyl rubble surround. This has actually lived 2.5 years, Chicago streets, going 30 to 40 miles every day from West Side to out by Wooddale for 2.5 years when I lived down on the West Side. And you really can't see that, but it just looks a little dirty, that's all. And that's sitting right in the same spot, different bike obviously, but these things are great. They hold up very well. They don't advertise them as waterproof or anything, but just being a solid aluminum cone, it works. The voice coil is underhung, and what's really cool is we'll show you with the bigger brother. This is the ND140. This weighs half a pound. So when you're talking about a bike, we got 1 pound for the 5 1/4s. The ND105s have a slightly smaller magnet structure. I think these are a little over 1/3 of a pound. So you got those. These are only rated at 40 watts. The ND105s are rated at 30 watts RMS. And they've got a 4mm X Max. But if you're willing to take a little bit of distortion, which, let's face it, it's a bike, a little bit of distortion, no one cares. These will actually go 10 millimeters, 20 millimeters peak to peak on the X Max. So like, it's hard to see with the surround because the surround kind of floats in there, but the actual cone moves a lot. And same thing with the passive radiators that I have here. So I'm running 2 4s with a single 5 1/4 passive radiator, which really isn't a problem because they also have a 20 millimeter peak to peak. And then for the amplifier, I'm using the Tiny Sign. It's a 4x100. I don't remember the model. Shit. I knew I was going to forget. So I got a little bit. I do know it has the ADAU 1701 DSP chip. Let's see. Tiny Sign. It's the TSA 8804 with the TDA 7498E amplifier chip, and I'm running it at 24 volts. It'll run up to 30 volts. It'll run up to 30 volts, and I'm also running it 2 ohms on every channel. I think it says it's 4x100. I think it's really closer to probably like 4x60, 4x45. Doesn't matter. It's more than enough for this little bike, and it surprised the hell out of everyone. Anyone that's ever heard it, it turns heads. Like, and part of it is the amplifier. Part of it is definitely the DSP. That is the only reason I bought the amplifier. It is the only reason to buy one of the Tiny Sign amplifiers over any of the other ones that are out there. Is that DSP is phenomenal. Normally with most of your speakers, when you're carrying a box or something, everything's directional. So like these ones, when I have this thing cranked, the ones up front basically blast me out. You can hear it, but I can hear it way more because they're pointing right at me. The 4-inch ones, I got 2 of them running full range off the front, and I got 2 of them running more for the rear subwoofer. Those ones are blasting down. So all that sound's hitting the ground, and it's just spreading out. And it sounds really good, really far away, 360-degree sound. You lose a little bit on the highs because those aren't as omnidirectional, but it still sounds great everywhere. And then on the back, the 5 1/4s, they're pointing straight back, but because of this little box shape, you also get it reflecting off the back, this back wall, and it actually projects out forward. Okay, so here we got the project file for the DSP on the StrayLights bike. I mean, I could spend hours on just the stuff that I know, which is not a whole lot. I tuned everything using my phone and using a little tone generator that the DSP can do itself. All of this stuff right here and over is actually part of a template that you get from Tiny Sign when you download their project file. So you don't have to worry about setting any of this up, but just for shits and giggles, this is just the Bluetooth signal coming in. It goes into a signal detector, which will actually turn a fader between your line level and your Bluetooth. So if the Bluetooth's off, you don't have to worry about any noise getting generated from it. Or same thing with the line. If your Bluetooth is on, you won't get any noise coming through the line. They got DC blockers on here just to help protect your speakers from your line level inputs. And same thing down with your tone generator. That splices into the signal, and it's turned on and off by a set of the buttons on the amplifier itself. The only things that I really added to this initial project is from the input coming in, I did a cutoff at 35 Hertz. So most of that, below that, you're not really going to hear, and most of your music, aside from some really, really heavy bass stuff, which a 4-inch speaker in a bike is not going to be able to reproduce very well anyways, most of your music is above 35 Hertz. So we're saving all that extra power so we can use it where we need it. And then from the original cutoff, signals split off, we got our front channel. And the front channel, we've got a dynamic bass boost up to 6 dBs at 50 Hertz. And this is scanning any frequency below 250 Hertz. If the peaks over 100 milliseconds are less than -5 dB, it will start adding a little bit of bass up to 6 dB at -25 dB, 3x compression ratio. So as the volume increases, the amount of bass boost drops down. So you're starting at below -25, you get the full 6 dB, and above -5, you get 0 boost. And this is again at 50 Hertz. From there, I went through and using my phone, you can plug your DSP in to your computer and you can adjust these values live. So I played a sample of different music that I'd be listening to, and then I adjusted the peak values. And I had an option, this part right here was part of the original template as well. They had an option for crossover. I liked the way that it sounded right out of the box, so I don't think I really touched anything. You just see like little fractions like 1 dB boost, 1 dB boost. It really didn't do anything on those. The rear channels, we got a mixer, so we're pulling the left and right into a single signal, and we're giving it a 4 dB boost. We're running 45 Hertz boost. Everything else is the same 6 dB as the one on the front channels. And then originally I had a cutoff, so I was going to lock it down to like 250 to 500 Hertz, somewhere in there. I ended up actually, if you see the little red, it's bypassed right now, so it's not even turned on. So for programming the controllers for the LEDs, I'm using LED Magic. There's LED Edit, and I think there's a couple other ones. Most of them you just lay out the pixels, and this example is one that I was just theorizing for my Eohor Romeo bike. Kind of just threw everything down. So this program is going to run 2 different channels. It's about 1800 LEDs, and it's real easy. Once you lay out how you want it to look, you just pick your effect, go through. We got a bunch of effects, so we can just pick one, and then this is an SWF file, really basic. And to do the layout, you can get really creative. So in the case of like my wheels, the wheel is a radial pattern. I didn't actually use a radial pattern. For my wheels, all I did was just the wheel. This is my wheel. It's just 32 lines, 21 pixels, that is it. And by picking different designs, it's hard to imagine what it looks like, but these 32 pixels are wrapped around. So something very, very simple as like 2 bars just going across the screen looks totally different when it's going around a radial pattern. So you got tons of freedom, and setting something up is just really easy. So you can just go into the config, start a manual layout, opens up another screen, and you got automated tools if you're just going to do rectangles. There you go. There's your grid. It auto connects. Now in the case of like that example I did with the Romeo bike, I actually laid out every single pixel, and it took me probably about an hour or so to lay all that out. Even just throwing it down really quick, because you have to throw it down and then align it. If you're using multiple ports, you have to align it to multiple ports, so it's a bit of a pain in the butt. But once it's done, you can reuse the same thing over and over and over again. And then you can just throw different patterns at it. So all we gotta do is, I'm doing SWFs, which we're gonna, and we can just pick a really simple effect. And this one is just a yellow and white bar, which probably wouldn't use for this bike. Let's pick a different one. So video effect. Let's do a nice rotation one. Let's pick a rotation. So that's this effect running. And then all you'd have to do is just go ahead, start record, and then it'll record some, stop it, and then you can edit and all that good jazz. But this is how I did the layouts on the StrayLights bike. So a little close-up view of the front. Right now I'm playing around with the controls, so the amplifier has full Bluetooth integration, pause, start, forward, back, volume up, volume down. You got the cycle analysis on the top, you got the DMA 80 3-inch speakers, and then I got the integrated phone holder. Just copy of the quad lock.
Neon trails in the dark like a comet in flight. Ain't no car, no ride matching this level of hype. Rolling streets with a glow, I'm the king of the lane. Every turn head swivel, they can't handle the flame. This ain't just a bike, it's a light show machine. Riding dreams on 2 wheels, a living, breathing scene. Oh, tires of the asphalt. LED veins pumping life. Nice my playground, slicing shadows like a knife. Handlebar steady, with the glow as my guide. Every spin of the pedal, electrified pride. Drill too sharp, cuts the night in two. We'll sing a melody, fluorescent hues. Crowds gather, jaws drop, no one compares. My bike's the main event, neon flares.